Welcome to the Athlete Climate Academy, where we talk with athletes, scientists, and communicators about the critical conversations that we need to have about the climate crisis. And a lot of focus in climate modeling is in the cryosphere, looking at ice and snow, and our guest today is someone who knows all about it. Today, we're excited to have Dr. Giulia Mazzotti with us, who's a postdoctoral researcher at the Swiss Federal Institute for Snow and Avalanche Research. She focuses on improving snow behavior predictions in forests, which helps make snow forecasts more accurate and reliable, which is crucial for managing water resources and understanding environmental changes. Giulia, welcome to the pod.
Thanks a lot for having me. I'm happy to be here.
We're both a little bit drier from the last time we were filming together in the Swiss Alps, and it was raining quite a lot. So we've got a 30-minute conversation now where we're both completely dry, and we can dig a bit more into your research because it's really, really interesting. So could you start by telling us your journey into the science where you are now and what sparked your interest in it?
So actually, it all really just started with a big love for the mountains and for the outdoors. So ever since I was a kid, I would spend my holidays in the mountains with my family. I would see this big Monte Rosa, massive glacier covered. It had a sort of fascinating attraction towards me. And I think this is what made me also go into environmental sciences as a study. And then during my university course, we had this course where we visited SLF, so the Institute for Snow and Avalanche Research in Davos in Switzerland. And there I saw, wow, you can live in the mountains and do research at the same time. And there are people doing their PhD here. I want to do this as well. And sometimes dreams come true. So I ended up doing a PhD at SLF. I was really into skiing at that time, so working on snow really was a good match. And then as you start working with snow and the cryosphere, as you said, you a bit automatically slip into climate science because climate change topics are just everyday business. So that's a bit how it happened for me.
And thus, you grew up around the Monte Rosa region, you are living in Grenoble at the moment, but spending time in Davos, you really get to kind of play in all these different places and get to see how snow cover changes, whether it's in the southern region of the Alps or the mountains are a little bit lower, a little bit more rounded, but then up in the Swiss Alps near Davos where they're very spiky, and these are all scientific words obviously, but very steep. And every place that you go to, the way that the snow interacts with the mountains and the forest is going to change, right? So your work focuses really on the dynamics of snow in forests. Can you explain how canopy structure and forest affects snow accumulation and the melt of it?
Yeah, as you say correctly, it affects both. So when you're in a forest and it snows, part of the snowfall will be caught by the trees and never even reach the ground. So we tend to have less snow accumulating in the forest than in open areas. We have less wind transport, so it's not as simple as that. But then, the snow that does accumulate in the forest also melts differently to snow in open areas. And there the processes are quite complex because at the same time, trees are shading the snow from sunlight. So this slows down the melt. But at the same time, the trees are relatively hot compared to the atmosphere, and every material radiates thermal energy, which according to its temperature. So the trees, or the fact that there are trees around, actually adds energy to the snowpack compared to open areas, and this might accelerate the melt. So whether snow melts faster or less fast in the forest relative to open areas really depends on the balance between this shading and this additional thermal energy. And that's quite complicated to balance out, and this is why the topic is also interesting and requires a lot of experimental investigation.
I mean, anyone who's spent time skiing or climbing in the outdoors will know that, when you leave a village or a town and you head up into the mountains, you go through lots of different types of landscapes, through the tracks that you walk in on to the shrubs and like the under canopy, I suppose, the smaller bushes and things. And then you get into the forest region before you get above the forest. So the dynamics of how snow interacts with the landscape changes like 5 or 6 times before you've even got to the top of the mountain. And you multiply that by different mountain ranges, how the sun interacts differently, at different latitudes on the planet as well. There's there must be such complexity in the things that you do. What are some of the key findings from your research that you found whilst studying this so far in your career?
Well, you pretty much put the pointer already at the right place. You say that, as you said, there are very different landscapes, and in fact, because the processes that shape snow accumulation and melt in the forest can be counteracting, so they have contrasting effects. It matters where we are in the landscape and at which latitude of what the final net effect is. And with my research, I've looked at this in a very detailed way. So I've studied forest snow distribution almost at the tree scale, and my work has been able to show that, it really matters how dense our canopy is for the strength of these processes and these effects, and also of where we're located in the landscape. So a forest at the north exposed slope has a very different effect in delaying or accelerating snowmelt compared to one in a south exposed slope. And I think, and my work has provided tools to also model that numerically.
Yeah, I suppose again that's something that people who spend time in the mountains will know, that northerly facing slopes and southerly facing slopes will react differently because of the sun's path across the sky. And that is true whether in the north hemisphere or the southern hemisphere. Just the way that the slope is facing is going to change. So when you're adding in all that complexity and to an environment that's fairly inaccessible a lot of the time, especially if you're trying to do science research and taking things with you, how do you go about modeling and finding data for places that are sometimes dangerous to get to and really inaccessible?
Well, nowadays we have amazing technology. I mean, I personally really still like to dig into the snowpack, do snow peaks, and really acquire ground measurements, because I think you also gain a lot of the process understanding by being in the field and seeing the things that happen and not just reading about it. And so I like to do the hard work, let's call it that way. But recent research technology has really massively expanded our opportunities to acquire data in places that are inaccessible. And here I'm obviously also thinking of drones. Now you can be close to your car, but and send a drone up in the sky with a laser sensor, for instance, that measures that's the sensor we often use to measure snow height. So we do surveys when there is snow and surveys when there is no snow, and by comparing these two data sets, you can calculate how much snow there was at the time of acquisition. And with such tools, we can now cover huge areas that would be much, much more difficult to cover if you were to, walk with your snow stake. And since snow cover is so variable in space, all of these tools that allow, or these technologies that allow us to acquire spatially distributed measurements, that's how we call it, they're extremely valuable because they also allow us to understand better these distribution patterns.
Yeah, I suppose things like drones that I work with a lot as well, they're really good at giving kind of like wide-reaching contextual data that if you can mix it with the ground research that, someone like yourself goes out and skis and is face-to-face with the snowpack and digging those and looking at it on face level, mixing those two different types of research data can be really helpful, right? To kind of back each one up.
Yeah, of course, and especially because a lot of these sensors that are mounted on drones, or even more complex when they're on satellites, we actually need a lot of research to first understand how to work with that data. Because of course, a drone, you think of an image, this is quite easy to interpret, but satellites, they don't always just measure optical imagery. Some of them simply measure wavelengths, and relating that to what we have on the ground, this really still requires measurements acquired on spot from the ground to actually understand what the satellite and what these sensors are seeing. So it definitely is a combination of the two. And it's a very exciting field of research at the moment. So there are a lot of satellites mission planned, there are a few satellites mission planned right now that are focused on snow and that will provide more information about snow researches on the snow resources on the Earth.
I hope we don't get to the point where people like yourself have to stop. You have to stop going out. There's always going to be a reason for you to go out and spend time in the field and in the snow where you love spending time. So it seems that we're putting
Of course.
lots of effort
I'm not worried about that.
into taking this data, whether through satellites, through drones, or ground measurements. Why is it so important that we understand what's happening with the snow on our planet? And obviously, we talk a lot about ice, but the snowpack is as important. When that changes, why is it important for us to study it, and what happens when it changes?
Well, there are a lot of levels to this question, and I think we can start by what we know best. I mean, in the Alps, very straightforward. The ski industry is massively affected, and the skiing, not just the skiing industry, but a lot of regions depend on tourism. And whether we like it or not, tourism will change because operating ski resorts as we are doing it now is not really sustainable. A lot of ski resorts, or most of the ski resorts, actually do depend on artificial snow to some extent. And of course, using water to create artificial snow takes the water from other uses. So there are energy and water resource related problems associated with that. And the tourism industry will change. And that's one of the impacts of climate change on snow. But then on a much wider scale, snow is also a water resource. So the water availability even further downstream in areas that never really see the snow is shaped by what happens in the mountains. And we will see, if we see earlier snow melt because the snow seasons get shorter, but this water will be missing at some point later in the summer. And this will affect agriculture and all of the water users downstream. So we will have to rethink the way that we allocate this water. And then it goes even further than that. Snow is also an ecosystem. We don't think of that so much, but in many regions, there are a lot of animals that actually depend on the snow cover to survive winter. And there are quite scary examples of this. So in more polar regions, let's say, these regions never used to see rain on snow events, so it never rained during winter, and the snowpack is simply isolating the grounds, and the grazer are able to dig there and access their food. Now, if it rains on the snow, this forms ice crusts that are inaccessible for these animals, so they can no longer get to their food, and we have seen reindeer die-offs because of that. So, as an ecosystem, snow is, or ecosystems that depend on snow are going to change with the changing climate. And I could continue this list, but these are three quite visual examples already, I would say.
So to take them one by one, then the ski industry across the world is one that depends on snow cover, and we've seen a rise in artificial snow lances and snow cannons to artificially amplify the amount of snow that they get in a season. We see the seasons changing. How does in many, especially of the alpine ski resorts, you ski straight through forests and down alpine passes. And how is forest cover and snowpack changing with ski resorts? I assume it's going to affect the ski resorts massively in the next couple of decades.
The forest cover in the ski resorts.
Yeah.
I'm not sure to what extent this is related in the European Alps, also because, I would say that most of the ski resorts or the big ski resorts are located rather above the tree line. In the US, it's a bit different because, we have a much bigger overlap of snow and forest, and there, with the whole problematic of wildfires as well, they're looking much more into detail into what are the interactions between the forest structure and the snow, and how can we actually manage the forest to best retain the snow while also being less at risk of fire. So there, the water management and forest management goes together a bit more than what we know here, than what we're used to here in the Alps. I am not familiar enough with the way they plan their ski resorts to comment on how this affects the ski resorts directly, but there's definitely an interaction between the management of the forest and
Yeah.
the fact that we want to retain snow in the
Yeah.
US. Here in
But
the Alps, we don't have that much snow in the forest anymore, unfortunately.
yeah. Yeah, you see that when you spend time in those kind of ski resorts. But like you say, the big one then after that is going to be how we start to look after water management. And when you do artificially create snow, then you are pulling water away from other places in alpine regions. And how does snowpack changes in the future, in the coming decades? When that changes, I assume that water resources are going to massively change as well, whether it's for agriculture, whether it's for snow cannons and snow lances, whether it's for hydroelectric power. A change in snowpack is going to impact everyone, right?
Yes, because as I said, we will have less snow further down. The snow will melt earlier, and it will be what we're used to having in the rivers from snowmelt will just be missing, or it will occur earlier in the year and then miss later in the summer. So, water uses will have to be reconsidered, or we'll have to take these changes into account.
And just on that third point, then with ecosystem changes, as is often the way with these things, like you said, there are things that balance out. So there might be a change in one direction, but it's counteracted by a change in a different direction. And the change then is just the net change that balances those two things out. So one of the things we're finding in the mountains is that snow lines are starting to get a little bit higher because of the hotter summers that we're having. That means that ecosystems are starting to push their way up the mountains as well. You see that with tree lines, you see that with animals as well. So there seems to be this interaction of, well, we're getting less snowpack further down the mountains, which means ecosystems can move further up the mountains and gain more space, but sometimes less water up there as well. So there's this fine balance within ecosystems, and ecosystems change all the time. But I imagine the way that the snowpacks change in the mountains, because we get this in the Arctic amplification, but in the mountains, like an alpine amplification, as it were. Is it changing too quickly for these ecosystems to actually adapt to?
This is an excellent question. And I think we don't always know the answers. I do. So it's not my field of research, but personally, I do have the feeling that these changes are happening a bit too quickly in some places. And again, I can pull the example of wildfires. So when we are seeing hotter and drier conditions in places that are used to be a lot wetter and colder, but these places develop a lot of biomass because of the wet conditions, and now suddenly it's very dry and hot, and you have a lot of material to burn. While in places that are drier in the first place, so more desertic or arid landscapes, this biomass never builds up. So when the change is too fast, the reaction of the ecosystem might be more catastrophic, so to say. And what's also to be considered, you said that ecosystems are moving up. Well, they are expanding their range. That's a good thing. But at the same time, they're pushing away. You can only climb up as high as your mountain is. And at the moment, there are ecosystems located at the highest points that are being pushed away by more competitive species coming from further down. So it's it's a tricky balance, as you said. And yes, it's I'm convinced that in places the change is too fast for nature to adapt quickly.
So in that adaptation, mitigation, there are things being done at the moment to start to monitor is the first thing. I'm glad that there's money, there's funding going into how do we monitor snowpack, whether through satellites, drones, and field research. That's great. But then what's the next stage? Do we start to think about how do we try and keep snowpack for longer? I'm not even sure what that would look like or how we'd even try and do that. Is it literally just adaptation to the change in snowpack, whether that's through tourism? In the tourists, we're gonna have to start pushing ski seasons back and around and move them. How do then we as humans adapt to these water resource changes, and how does the ecosystem start to adapt to that? So what can actually be done as physically changing things to adapt to this change in snowpack that we see?
Well, as long as the climate is warming, we cannot avoid shifts in snow regimes. Snow can only exist if it's if it's colder than 0 degrees or 0 degrees. So, I mean, if we want to preserve snowpacks and limit these changes, the only way is to implement policies that keep climate change within limits. And well, I know this is easier said than done, because we see that the implementation is actually not as straightforward as we'd like it to be. So there's nothing we can do about this link. There are some, at the small scale, things can be done, like covering specific areas of a glacier, but in some ski resorts, they cover some slopes, or they create artificial snow that they try to preserve over summer. But these are small amounts. This is not scalable. These are not scalable techniques. So I do think that in the long term, adapting to a changed regime is what we need to do. And as I said, some resorts that are now relying on the ski industry but are just simply located at too low elevations, they will have to rethink what they offer to the tourists. But it's not an easy process, that's for sure.
No,
and same for ecosystems. They might not adapt quickly, but they will adapt. But I think nature is quite good at adapting, better than humans.
Yeah, I mean, nature's really good. Humans are good if they want to do it. Like we've seen that over the years. So it seems that whatever happens, unless we start, well, even if we cut out fossil fuels right now, we know that there's X amount of warming already built into the models, that we will warm another few points of a degree, regardless of us taking out fossil fuels from our energy systems right now. So the interesting thing about snow is that it's one of the things that it does really well is that it keeps the Earth cooler. Anything that is bright, like glaciers and snow and Arctic ice and Antarctic ice and ice in Greenland, it works really well to reflect sunlight back into space. And the worry is that with a reducing snowpack, not only is it going to have all these consequences we've already talked about, but it's also going to have a feedback loop where we get darker environments where there used to be bright environments like snow and ice, and that's actually going to amplify the warming that we see. Is that right?
Absolutely. Yeah. You explained it better than I could have.
So I'm trying to come towards the end of the podcast. I'm trying to find like a positive way out, but like with snowpack specifically and ice, it seems that we are just by the end of the century just heading towards a place where we have a lot less than we used to have, and there's not a lot we can do about it.
We are headed towards a place where we have a lot less, but we are not headed towards none at all.
Right.
And so if we limit temperature increases as much as we can, we can still save some of the glaciers. Let's put it that way. And snowpacks are not going to disappear within the next 10 years. They're just going to last shorter and be located at higher elevation. But we will not lose the snow within 10 years from now. But it will be reduced. That's what we cannot avoid.
Well, I mean, that's a hopeful message that we're not headed to a place with this, and especially in our lifetimes, I would hope. So if there's one thing that people can start doing to preserve snowpacks, one thing that ski resorts can do to help preserve snowpacks and to make them last longer, is there anything that individuals and organizations can actually do for that? Or is it a case of the best thing we can do is still like vote in progressive candidates that have climate change in mind? Or is there actual physical things that anyone can do to help preserve snowpacks?
I think just snowpacks are so tightly linked to climate change that everything that positively affects climate policies or mitigates one's own carbon footprint is helpful. You will just never see the direct impact of individual actions. So it's definitely an issue that needs to be solved or tackled at the large scale. But of course, every contribution, and also just the fact of talking about it, being aware of these topics. A lot of us like to go out in the mountains, do like to play in the snow, and these are topics that you can relate to, and making climate change tangible with these topics, I think, can help people can help motivate people to also become more engaged in the political actions, or in actually voting for the right parties and so on. So I think the fact that we have some also emotional connection to this kind of topics can help. But yeah, it's definitely a large scale problem that requires a large scale solution.
I think so too. So looking into the future for you then, with your research, what's the next kind of steps for your research study in snowpack in forested environments, on climate change adaptation strategies, that kind of stuff? What is next for you on the horizon?
So as I said, I think we're not going to lose the snow. So I'm confident that I will be able to work on snow for a lot more years, which is nice, of course. But as we were discussing a bit right now, it's very important to put these insights and this improved understanding into action. So besides the actual science, I'm motivated to engage more in making this science understandable to the public. And yeah, this is what we're doing now, actually. And see that a broader audience understands what's happening around us and becomes motivated to take action. So yeah, I see some future steps in my career involving more education and outreach, probably. And in terms of research, there is a lot to do. You wouldn't know where to start.
Well, I'm sure there's some really exciting stuff. Don't let the drones take over. Still get out there and spend time in that environment. In the
I
winters,
will also
I'm sure
continue
you will.
to dig in the snowpacks, that's for sure.
It seems to be a running theme. People digging in the mud and digging in snow on this podcast. Everyone seems to be doing it. And I think that's the best way to do science, is getting your hands dirty anyway.
Yeah. So maybe, we've talked a lot about snow in forests, and I said that less snow accumulates in the forest relative to open areas. So to dig even deeper into the snowpack, I think I'm trying to expand my research to above the tree line, so that I will be able to dig into deeper snowpacks.
Yeah. So keep digging in the snow. That's the main message. Well, thank you very much. Dr. Giulia Mazzotti is postdoctoral researcher at the Swiss Federal Institute for Snow and Avalanche Research. Giulia, it was such a pleasure having you on the podcast.
Yeah, thanks for inviting me.